Hi, myself Naveen Kumar Saini. In the course Wireless and Mobile Communication, today we are going to discuss the two very prominent technology which build up for the 4G networks, up to the 4G networks. So that is the Edge and the UMTS. So Edge technology is what? This is the enhanced data rate for GSM evolution. So basically this edge technology is the enhancement of GPRS system on the GSM network. So this GSM network we have discussed already. So global system for mobile communication. So this GSM system was 2G networks, and then advancement of GSM was GPRS, which was a 2.5G network, and next is the in that series, that is the edge network. So this is the 2.75G network. So as we said, this is the GSM evolution part, enhanced GPRS. So this is advancement of GSM architecture, and they have used that architecture for the deployment of the edge network. So here we see that this GSM network, which was used as 9.6 kbps data rate, and then GSM at plus use the 115 kbps per second. So it means there is a enhancement in the data rate. So to get up to the 2.75G network in the that is edge network. Okay, so it is bifurcated into two ways. First is the edge, and then it is the WCDMA. So this one is bifurcation, or you can say this technologies was proposed by the 3GPP, third generation partnership project. So here in this edge network, it is digital mobile phone are used, or we can say this is digital mobile phone technology that allows improved data transmission rates, and the reliability is more as compared to the GSM and GPRS systems. So this 3G edge network is considered as the pre 3G. 3G is the third generation, which was proposed by the 3GPP, third generation partnership project. So this is the just previous or the pre 3G radio networks or radio technology, which was developed on the GSM networks or GSM architecture, which is begin in the 2003. So initially by the Singular, and now it is the AT&T in the United States, which deployed the edge network onto the GSM network. So this in this case, the edge that can function on any of the network with the GPRS deployment. So it provided the carrier implements, and the necessary upgrades are done onto the edge network. So that is why this is just pre of the 3G network. So because the 3G network is the UMTS network, so just before that, that is a 3G. So just before that, that is why we call it as the 2.75G network. So in means it is proposed for increase or enhance the data rates of the into the system. So as in the GSM network, so this GSM network was there for introduction of the voice network, and then GPRS was introduced for the to increase the data rate as well. So this edge network is also used where the packet switch network is there, right? So packet switch network, like just like for the internet connections. So in this edge network, internet connections was there. So packet switching technique was introduced, or was inculcated into the GSM or the GPRS, that is the edge network. So this sequence must be clear to all of us, that this is a GSM, then GPRS, and then this is the edge technology, and then this is the UMTS. So this is the flow of technologies or generations. So this generation was 2G generation, this one was the 2.5G, this one is the 2.75, and this one is the 3G generation. Okay, so there are some of the features are there in the edge technology. So it is a technology that gives the GSM the capacity to handle the services for the third generation of the mobile network, and it enables the services like multimedia files transfer and web browsing was there. And then the next important point which was introduced or the facilitated, that is the video conferencing, right, which is easily accessible from the wireless terminal. So these are the very important applications of the edge network deployment, where the multimedia files transfer occur, and then web browsing, that is internet, and then the video conferencing. So video conferencing is another unique feature which occurred into the edge system. So using the edge, operators can handle triple subscriber than the GPRS. So triple, it means the capacity of the network can will enhanced in the edge network as compared to the GSM and the GPRS system. So it also enhance the data rate, that is the 3 times of the GPRS, and then extra capacity to their voice communications. So these are very important features which is achieved through the edge network, and this edge network was proposed by the 3GPP third generation partnership project. So here the edge is capable of offering data rates of to 384 kbps, and the theoretical this value is 473.6 kbps. So these are the practical value which is achieved, and this was a theoretical value which was expected to achieve up to 473.6 kbps. So there are a few important key features or the key elements in the edge technology, right? So here first and very most to enhance the data rate, we have the use the 8 PSK, right? In the GPRS or in the GSM we use the GMSK modulation scheme to enhance the data rate, but this data rate was very less. So in the edge system we have used the 8 PSK. So what it means? It means 3 bits per symbol. Okay, so 3 bits per symbol means it is modulated the 3 bits at per by one symbol, and due to which the data rates are enhanced. So in this modulation format has been changed 8 PSK, which provides the or convey the 3 bits more for the modulation. So it means that when we use the more bits for modulation at a time, so it will enhance the data rate. Second changes which occur in the GPRS, that is the base station. So in that the some small changes have been made in the base station implementation. They have used in the base station in different way, different RNCs were there, radio networks controllers are introduced into that to enhance the capability or capacity of the base station. Upgrade to the network architecture. So they have changed the architecture, but the basic architecture was the same, that is a GSM. So this GSM architecture was improved or enhanced as per the requirement. So here it offers the IP based transfer and transfer rate, which makes it necessary to add some more networks elements. So by using this upgradation in network of edge system, the IP based networks was capable to introduce more and more component, or the complexity will be more. This may be the disadvantage of this technology or the existing technologies right now, but the benefit or the applications are more. So how to get the more benefits or applications? So that if we introduce more component into that as per our requirement, in that case the data rate or the voice quality will be improved. Second is mobile stations. So it uses the edge facilities. It is mandatory to give a GSM edge handsets, because each and every set can't be upgraded. So generally the GSM network is used for the to improve the voice quality, but for improving the data rate, we upgrade the system and we achieve the data rates up to in hundreds kbps, right, more than 100 kbps. So this data rates can be improved to change the architecture of the GSM network, where we reach up to the edge network, that is a pre 3G third generation partnership, third generation. So here enhancement data rate for GSM system, as we said, this is the 2.5 G network, but it is now 2.5 is the for the GPRS. We can say this is for the GPRS, but edge techniques, this one is for the that is the 2.75G. So we have to make the correction for that. Then it enables the data sent over GSM TDMA system at a speed of 384 kbps, which is nothing but this is the practical value which achieved through the edge network. So here the comparison is there between the GSM and the edge technique. So in comparison, parameters are there. First one is the modulation, then bit rate, channel bandwidth, pulse shaping, and the modulation type. So in GSM, for modulation technique which was used, that is GMSK, and it is enhanced to the edge, that is the 8 PSK, right. So this enhancement is used to increase the data rate. So in the GSM, the bit rate was 270.833 kbps, and into the edge network it was 812.499 kbps. Similar to that, when we talk about the channel bandwidth, so channel bandwidth is same in both the cases for the GSM and the edge. It is the 200 kilohertz band is there, and here edge same 200 kiloband is there, hertz band is there. Pulse shaping technique which was used in the GSM, that is the Gaussian pre-filter, that is BT, that is equal to this is the bandwidth time product, that is a 0.3. But in the case of the edge network, this is used the linearized GSM pulses are there for the pulse shaping to reduce the ISI. Then modulation type which was used, or you can say the different filters which are used in the GSM, that was the non-linear and the constant envelope is there. But in the case of edge, only the linear modulation type is used. So here is the advantages of using the edge network. It moves more quickly, connection is always on. In the case of edge, it is more trustworthy and the effective architecture is there as compared to GSM or GPRS or any other architecture, and it is very economical. Some of the disadvantages there, because we are adding more and more components into the architecture of GSM. So obviously the battery is used up to the faster, but battery will be consumed very large. So this is the some kind of disadvantage of this network. Hardware needs to be upgraded. So all the time the hardware upgradation is required, because we are using the IP connections that is used for the internet. So obviously it requires the more battery power will be consumed more, because internet connection will take the more and more bandwidth. So to for using the more bandwidth, we have to transmit the more data. It means we have to pump by the power to that data to transmit that. So it means we require the more battery in the edge networks. Okay, so now come to the next point, that is the advancement of edge network, that is UMTS. So UMTS is nothing but this is the universal mobile telecommunication system. So we will come to this UMTS section, which is the one step ahead of the edge network, which is now we are come to the 3G network. So here this is again the advancement of the 2.75G or the we can say in the edge network. So what it stands for? So this universal mobile telecommunication system is carried out by the ETSI in parallel with the IMT 2000, okay, to harmonize its effects with the ITU. Okay, this was the organization through which, these are the union through which by using the IMT 2000 standards, UMTS technique or 3G network is coming to the picture. So this is the 3G network, which has some features like broadband, packet based transmission is there of the text, digitized voice, video, multimedia at data rates up to 2 Mbps. So this is the very important feature which achieved in the 3G network. The data rate is increased or improved up to 2 Mbps by changing the architecture of edge network, right? Or we can say this also changing the network in the GSM. The basic concept is same, but the enhancement in the architecture is used to improve the data rate. And this UMTS is used in the technique that is CDMA system. Okay, so in the CDMA system, this UMTS technique is used, and but it is important feature is the wide band. So in the UMTS, when we use the CDMA technique, so in this the bandwidth of the signal will be spread. So kind of SSM, spread spectrum modulation, which was the modulation technique which was used. Then so that is why we call it as the wideband code division multiple access, or the WCDMA. Then the higher bandwidth also enable the video conferencing, that is the IPTV. Then the computer and the phone which users can be constantly attached to the internet. So that is why this is also the always on network in which the different users can constantly attach with the internet, means all the time the users can access the internet. This is a very important feature, or very nice feature for the UMTS system. So obviously when we improve the more data rate, data rate will be improved. So in this case the internet access will be easily, so there will not be any delay in the browsing of the network. Okay, so here we see in the short that this UMTS comprise one of the core network, and this core network is connected with the RNSs, and then this is the radio network systems, and then these RNSs are connected with the mobile stations, right? So this is the basic diagram of the UMTS, in which this core network is connected with the public networks like PLMN, PSTN, ISDN and PSDN, right? So the purpose of UMTS is comprised advancement of 2G and 2.5G systems, which were incompatible around the world at that time. So worldwidely it was used UMTS, which have the multiple technology inside the UMTS. Tri-band phones were used, dual mode phones are used in the UMTS. So requirement is now different, purpose is same, always connected using the internet. So purpose is same, but the architecture is now different, but that is use the different band phones. Okay, so not all the time the GSM phones are used to access that. So UMTS kind of phones can access the previous technology like GSM and the edge technology, but if we have the mobile phone that is only supporting the 2G network, this 2G network phone cannot support the 3G networks, but opposite of that 3G network phone can support the 2G network or the just previous 2.75G kind of networks. So to deploy and to develop a single standard that would be accepted around the world, so one device should be able to work anywhere, increase data rate, which I just mentioned, a max 2.0848 Mbps, or in kbps it is 2048 kbps. So this is a phone which comprise the UMTS, GSM, CDMA phones. So it is already, it was accepted universally globally in the market. So spectrum, when we talk about the spectrum and the bandwidth for this case, so as we said, this is a WCDMA. So if for this one in UMTS, it is used the 5 megahertz of total band. So one band is of frequency is there which was used, and this is usable frequency 3.84 megahertz, and side are the guard bands, right? So this is representing only the this is representing about the Fourier transform, we can say, of the spectrum, in which these are the null points at which there is a zero ISI, right? So the band of frequencies in the electromagnetic radiation spectrum for UMTS has been identified as the frequency bands. So these bands are 1885 to 2025 megahertz for the future IMT 2000 systems, and 18 1980 2010 megahertz, and the 2170 and 2200 megahertz for the satellite portion of the UMTS system. So these are the frequency bands and with different applications, which was where the UMTS architecture was used. So this UMTS works on the two modes. First mode of operation of UMTS is UMTS frequency FDD and the TDD. So frequency division duplex and the time division duplex. So what is the difference between the frequency division duplex and the time division duplex is that in the frequency division duplex mode, there are two frequencies are used, one for the uplink and the another for the downlink. So we can see in the figure as well, in the FDD system, the two frequencies F1 and F2 is used. So one frequency is used only for the uplink, which is from the mobile phone to the tower, and the second frequency is used for the downlink, which is from the base station to the mobile phone. So two frequencies are used in the case of the FDD, frequency division duplex. But in the case of the time division duplex, in this one, so in duplex mode only one frequency is used for both the uplink and the downlink, but the frequency is divided into the time slots for uplink and downlink communication. So what it says, in the time division duplex, what happen, only one frequency will be used, it may be the F1 or F2. Okay, so F1 and F2. So F1 frequency will be used for the uplink and the downlink. So here F1 frequency is used. So at one time instant, or you can say at one time slot, this frequency will be used for the uplink, and in the second time slot this frequency will be used at the downlink, right? So in the difference is very much clear to all of you, that for FDD two frequencies are used for the uplink and downlink, and but in the case of TDD the one frequency is used for uplink and downlink. So at one time period this frequency will be used for the uplink, and in the second time period this frequency will be used at the downlink, right? So this was the mode of operation of UMTS. So now come to the architecture of the UMTS. So this is a complex architecture of UMTS which comprise the basic three parts. You can say the three parts. So first one is the user equipment, second one is the UT-RAN, and third one is the core network. So in that user equipment is comprised of user SIM and the mobile phone. So this as we have the mobile phone, into that mobile phone we have the SIM. So this complete mobile phone we call it as the, we called into the UMTS, that is the user equipment, UE. Okay, so this is the UE. Then we have UT-RAN. So I will discuss in the upcoming slide about the UT-RAN. So this is the architecture or the central part of the UMTS. Here this UT-RAN comprise the nodes and the INCs. So these nodes, or node B is nothing but the base station, which is which coordinate all the mobile phones which are connected with the nodes, right? So in simple words we can say node B is nothing but the base stations. So this base station is the advanced form where the signal and processing is more complex into that. So that is why we call it the node B, okay, where the complexity of the signal processing is there. So in this the node B comprise many user equipments, and these node Bs are controlled by the INCs, radio network controller, and these INCs are controlled by the different MSCs or the SGs, SNs and so on, right. So what is the basic terminologies which were used here? MSC, this is a mobile switching center, mobile switching center services, that ME at its current location for the circuit switch service. So MSC is, if we know about the GSM network, if you studied, then MSC was responsible to coordinate all the BSCs of the in the GSM network, right. And these BSCs was comprised with the BTS, and these BTS were connected with the mobile phones. So this sequence you must be know about the GSM, then only these things will be clear to all of you. Okay. So here in this case, we as we said, this UMTS is the advancement of the GSM network, right. So this terminology will be there. Next is the GMSC, where the gateway MSC serves UMTS, where it is connected to the exit CS network. Okay. Then we have HLR, this is a home locator register, in which the database of the user or the mobile phone will be stored as the master copy of the mobile user profile. Then the VLR, visitor location register, so the database holding a copy of the visiting users when we are moving from one cell to the another cell. So this into another cell, you will be the visitor for that. Okay, so that copy will be stored into the VLR. So this must be clear to all of you, what is the meaning of all these things. Then next is the GSN. So in the GSN, so this is the gateway serving GPRS support node, that the node that is accessed by the packet data network. It contains the routing information for the packet source which is attached with the user. Okay. Then we have SGSN. So in this SGSN, this is the serving GPRS support node, in which router kind of things, where the packet switch services will be there, which routes the information from the user, from one user to the another user to make the connection. Next is the node B. So this node B is the 3G base station, as I just said, which handles radio channels, multiplexing, demultiplexing of the data and voice, right. So these are the node B, the kind of base station in the GPS GSM, but we call the 3G base station in the called the node B inter UMTS. Then we have RNC. So RNC is nothing but the radio RN controller, which controls and manages the multiple base stations. So this RNC, radio network controller, which controls all the base stations into the network. So combining all these things is called the UTRAN. Okay. Okay. Then on the core network, we have SGSN, GGSN, HLR, authentic control, MSC, VLR, GMSC, and then we have the internet or the PSTN, right. So these are the components of the UMTS. Now come to the architecture of UTRAN. So what is the UTRAN? As simply we said, this is comprised the node B and the RNCs. Okay. So this UTRAN terminology is the UMTS terrestrial radio access network, which has two elements. First one is the RNC and second one is the node B, right. So UTRAN is subdivided into the different or individual radio networks, RNS, where each RNS is controlled by the RNCs, right. So here whatever functionality is happening or whatever functions is happening into the node B, so this node B will be controlled by the RNC. So in the UTRAN is kind of the MSC of the GSM network, right. So all the handover or all the procedure which occurs, so it occurs into the UTRAN network. So we can say UTRAN is the heart of this UMTS system. So here the RNC is connected to a set of node B elements, each of which can serve one or more several cells. So in the cellular system, this all deployed, node Bs are deployed. It may be kind of pico cells, or it can be kind of femto cells, macro cell, micro cell. It depends on the geographical area and the geographical conditions. It may be the rural area, it may be the urban area. So based on the environment, these networks, this deployment of the node Bs are different. Okay, some in at some places use the low power node Bs, and some places it use the high power node Bs. So if we have the small, if we have kind of we can say the urban area which is very congested, so in that case the low power node Bs can be utilized. If we have the rural area kind of environment where we can use the uh, where we can use the different high power node Bs, right? Then RNCs, the RNC enables autonomous radio resources management, RRMs, in by the UTRAN, and RNC handles protocols exchange between the this IU, IUR and the IUB. So these are the interfaces which were used between the node Bs and the RNCs. So here this RNC provides the air interface between the UE and the core networks, and node B also participates in the power control of power control between the users. So RNC, as I just said about the radio network controller, node B is the physical unit of the radio transmitter receiver cells. So this is another way of representing the network of UMTS, as I just said previously. So these all are the components, so which we have discussed about that how it looks like between the core network, and which is the circuit switched domain, and this is the radio access network RAN, okay, which is connected with the different PSTN network or the internet, right? So these are the interfaces. So IU interface, that is interface between the UTRAN and the CN. IUR interface between different INCs are there. IUB, these are the radio and network interfaces. So this interface between node B and the RNC, and UU is the air interface between the mobile station and the base station. So these are the key specifications or difference between UTRA FDD and the UTRA TDD. Okay, so these differences are very important. The parameters for that is multiple access method, channel spacing, carrier chip rate, spreading factor, time slot structure, frame length, multi-rate concept which was used as the multi-core and OVSF, that is OVSF is orthogonal variable spreading factor, right? And the multi-core and multi-slot and the OVSF is also used. Burst type, in the case of UTR there is no requirement, but in the case of UTR TDD it used the traffic burst, random access burst, synchronization burst. Detection technique which was used, that is the coherence based on the pilot symbols and the coherence based on the mid ambulance. Then dedicated channel power control. In this, the UTRA FDD uses the fast closed loop, which is of at the rate of 1500 hertz rate, and in the UTRA TDD it uses the uplink separately open loop 100 hertz or 200 hertz rate, and the downlink closed loop max 100 hertz rate. So this one is all about the edge technology and the UMTS technology, and in the UMTS technology we have discussed about the UTRAN. So I hope you understood the concept behind the edge and the UMTS technology. Thank you very much.